Hi, I'm Luka Čehovin from University of Ljubljana, and the work that I'm presenting today is about improving part-based appearance models for single object visual tracking using something that we call anchor templates, but it's generally just like templates that we accumulate over the sequence that we're tracking, so to improve like then performance of the entire model. So what we have actually observed when looking at results of existing benchmarks on single target tracking is that part-based models or trackers that use this kind of models tend to perform well on deforming targets, which is kind of makes sense. They are more robust than holistic models in this case, but on the other hand, they are less accurate in many cases, especially if there is no deformation or if there is like some uncertainty in visual data, for example, due to partial occlusions. And this leads to then the accuracy reduction. And we believe this is because of the number of parameters that have to be estimated to match such a model to a new image, which is quite large in case of part-based appearance models. And this, because this process is self-supervised, this leads to greater errors and faster accuracy reduction. And what we propose is like a mechanism for controlled graduation in estimating these parameters. So more specifically, our appearance model is like a hierarchical structure where we have on top a memory system, so like a set of templates, snapshots accumulated over the sequence as we go along. And then we combine this using a segmentation layer, so it's like some simple segmentation to get some coarse shape of the object. And on the bottom layer we have a constellation of parts, and this is like the part-based model, and we have each part describes the object just using some simple grayscale histogram, and those parts are then replaced by new parts based on this higher level information. So more specifically, our tracker works in 3 modes throughout the sequence. If the object is still, or it's like not deforming at least, we have like a template that we can use, so it's like it can be matched well, then it's basically just a simple template tracking. But if we actually if the object is deforming, then we cannot find the template, then we rely more on parts, like on this part-based description. But perhaps the most novel approach here is like this intermediate mode, where we actually have a template that is still reliable, but it's not good enough for detection. And in this case, we use it as some sort of spatial prior for updating the entire model. And this we have shown experimentally that using this intermediate mode, we can significantly improve the performance. So we have evaluated our approach on 2 existing benchmarks, VOT 2013 and 2014, and we have shown that it improves like the performance of especially comparison to existing part-based methods, but also to like other state-of-the-art methods quite significantly in terms of accuracy and robustness. And so this is not the end of our work. We plan to extend the appearance model in terms of long-term online modeling of an object and introduce some prior appearance constraints. So if you have like a specific application, for example face tracking, to introduce some additional models, some constraints that could help with this. And using all this, we can then also proceed to detecting occlusions explicitly and failures of the entire model. So the code is available online already, and if you want to know more or see some videos, because I didn't include them here, you can stop by my poster. So this is like B9. Thank you.